All right, so we're in section 17. Now, again, I'm just going to, talk about using Sage and reset and as a variable. Again, the hope is that you've studied this section of the notes and you're prepared to see how Sage can handle some of these problems over here. Assume, and what are we going to assume? We're going to assume that n is an integer. All right, no error so far, huh? And let's do this now. I'm getting a little tired. I'm going to copy paste, and then we'll talk about what the code means. All right, so this is defining a function an, and an is equal to 5 over 2n squared plus 4n plus 3. I'll put that down. Now it's a function you could evaluate the function at like 1. Whoops. You get the idea. You could evaluate this. All right. Let's type in bn. I think I can do that. B is a function of n. And what is it? It's being assigned 1 divided by n squared. All right, let's look at the next one. The next one says limit. And it's a limit of an. It has a lot to do with what we've done in the notes. Divide by bn. Oops. And then it's a limit, and n is going towards infinity. Now, granted, I know this looks strange to you. I'm putting OO. That's supposed to look like an infinity. All right. And it says 5/2 over there. Now, let's do the next line of code. It says assume that n is greater than 0. By the way, n is still an integer, by the way. All right. And what I want to do is I want to solve something. And I want to see, again, someone says, what is it going to produce? Well, I'm just typing in code. And I want to do this thing over here. And again, you might be confused by output. You're going to be confused by output, generally speaking, if you don't understand the problem. But anyway, what does it say? That's a weird statement over there, isn't it? Really weird looking. I'm looking at that. I can't understand that. It says n less than 0. Then it says n greater than 0. All right, let's try something else. X equals var. By the way, you do not have to define X as a variable in Sage. It's given that one. All right. Wow. Integral is divergent. Okay. This is something we've done in the past, by the way. By the way, I want to go back. I don't need to scroll back. I'll look at this code over here. And someone's going to say is, could you solve that? Now, granted, someone says, well, I just typed it in. I don't understand the output. We actually did this one in the problem set. So here's, again, the problem about this over here. Typing stuff in and getting output may not be helpful unless you can do stuff by hand. This is why it's so important that you've done the prior material before typing this stuff in. Let's go scroll back over the notes, and I want to see if I see that. There's a lot of notes, aren't there? A lot of work, too. Gee, I hope it's there. Well, I think it might be this one. Let me go back to my Sage. And someone says, why do you want to do that? Look at how long that error message was, right? Let's see if this one. So it's, yeah, look at it. And what am I doing? It's, I'm comparing something over here. Yep, making a comparison. We did it. All right. Did we do that? Yeah, we did that in class. I hope you know there's a connection between the two problems. And that's important. You notice a connection between them. Thank you for your attention. Oh, before I do that, though, I want to point out, please look back over the notes and see if you can handle these problems using Sage. But the bottom line is make sure you can do these things by hand as was done in class or lecture time, right? Make sure you can do these by hand. You're not using a machine. And someone says, why am I using a machine? Well, the thing is you need to learn how to use a machine because when you move forward, machines are going to become incredibly important in the solutions of problems that can't be done by hand. But if you can't formulate something by hand, you're never going to get to the level of a machine. Thank you.